Hello everyone. This is Dr. R.Sasikumar, Professor, Department of Computer Science and Engineering from RMDEC Engineering College. Today I'm going to take about the concept of instruction fetch and execution step for load and store instruction. In my previous video, I have given that how to execute that R format instruction and how to execute that branch instruction. So in this video, I'm going to tell about how to execute that memory operations, that is a load and store instruction. So before move on to that load and store instruction, this is the fundamental step to understand the concept of instruction fetch and execution step. So how the instruction will be fetched means for this is the overall diagram. So the first and foremost step is required for a program counter because the program counter is the initial step of the basic operational concept. This program counter always points the address of the first instruction or address of the next instruction. So that program counter which supply the address to MAR. So the MAR is nothing but what memory address register. So once the address is available on that MAR, then it is going to read the instruction from memory by passing the address to memory. So once if the address is matched to that existing memory location, then the corresponding instruction will be fetched. Then that once the instruction is fetched on that fetched from memory means what? Then that instruction will be transferred to IR. So IR is nothing but what? Instruction register. What is the role of IR means what? It is going to analyze and decode the instruction. So what type of instruction is currently available and how many operands are available in that instruction. Everything will be given by the instruction register. After decoding that instruction, then with the help of memory data register, with the help of control signal, the data can be read from that memory and that data will be stored into the general purpose register. Once the data is available in the register, then with the help of control signal, the ALU can do that necessary operation. So totally, for executing one instruction, maximum 5 clock cycles is required, minimum 3 clock cycles is required. For R format instruction, step 1, step 2, step 3 is required, and step 4 is not required, and step 5 is required. For branch instruction, conditional branch instruction or unconditional branch instruction, first 3 steps are required, and the step 4 and step 5 is not required. There is no action for step 4 and step 5. But which instruction is suitable for executing all the five steps means what? The load instruction. So the load instruction, the compulsory use all the 5 steps. Okay, so the load and store instruction belongs to what? I format instruction, and it is nothing but what a memory operations. So this is the way to fetch the instruction from memory. And what is the use of that instruction address generator means what? Once the instruction is move on to IR, then the program counter will be incremented by 4. So the, for example, the program counter initial address is 1000. Okay, once the address is that in that address will be transferred to program counter which supply address to memory address. Then the memory can read the data from the instruction from that memory once with the help of MAR. Once the instruction is move on to IR, then the program counter will be incremented by 4. Here, when the 4 will be selected means what? If the program counter address is incremented normally, then the multiplexer 0 will be selected. So what is the use of that multiplexer means what? Wherever we have more than one input, there itself we have to use, we must use that multiplexer. So whenever we have more than one input with help of multiplexer, we can select one. So according to this concept, the program counter is increment by 4 means what? The multiplexer selection line will be 0. Okay, then the 4 will be selected. So with the help of added, the 1000 plus 4, then 1004 will be selected, and that 1004 address will be updated into program counter again. Now the program counter points the address of the next instruction. Suppose instead of normal instruction, if it is a branch instruction, then we have to update the program counter address compulsory. So that's why the selection line will be 1. If the selection line is 1 means what? Then the branch address is a taken branch. So we have to update the program counter address by force. So this is the fundamental steps to execute the one instruction. Now we move on to example. So this first example, load instruction. So load R5, comma X of R7. So here we have a two register. One is a R5 register and another one is a R7 register. R5 is nothing but what? A destination register. R7 is nothing but what? A source register. So the content of R7 not available, not directly available. So we have to add with that offset value, then only the data can be available. So how to get the data from that memory means what? The first step, the program counter. The program counter address supplied to memory address register, MAR. With the help of MAR, the system going to get the instruction from the memory. Then after fetching the instruction from the memory, that instruction will be stored into IR. Before into move on to IR, the system which will process the read operation. Once the read operation is completed, then the corresponding instruction will be transferred to IR. So what is the role of IR means what? IR is nothing but what? Instruction register. It is going to decode and analyze that instruction. Then after performing that analysis and decoding operations, the data can be fetched from that memory. Then the ALU will perform the operations. So when the program counter will be incremented by 4 means what? Once the instruction is moved on to IR, automatically the program counter will be incremented by 4. So the first step it is nothing but this is the mandatory for all type of instruction. Second step, the decode instruction. After performing the decoding operations, then we need to fetch the data from the memory with the help of MDR, memory data register. Here, what is our input means what? R7 is a source register. So the content of R7 will be transferred to register RA, but the actual data is not available directly. So we have to add that offset value. Once the content of R7 is added with offset value, then only we will get the original data. So in step 3, we have to perform the add operations with the help of ALU. The data can be added with the offset value. Then that is not the original data. That address will be supplied to register RZ. Again, in fourth step, the content of RZ will be transferred to memory address. What is the meaning of that memory address means what? Here, so far, the data is not available directly. So once the address is available, so we need to perform the read operation. After performing that read operations, then the respective data will be transferred from the memory to register RY. So once the data is available, then last step is what? We need to transfer the data from memory address into register. So that's why the content of RY will be transferred to R5. So uh, uh, we have a 3 format instruction: R format, I format, and J format. Only in memory operations, the load instruction alone using that all 5 steps. This is the important concept of load instructions. So the load instruction which use all the 5 steps compulsory. So this is the one example. Another example I'm going to tell about another memory operations. We have a store operations. So we need to store the data into that specified memory location. Here the data is available, but the location is not yet available. So before storing the data into that memory, we need to find out the location address. Once we find the location address, then we can store the data into that specified memory location. That is a store operation. So as usual, that first step is mandatory for all the instruction. The program counter, which is supply the address to memory address with help of memory address register, the system can read the instruction from memory. Once the instruction is moved on to IR, then the program counter will be incremented by 4 automatically. The second step, the IR, the role of IR is for nothing but what? To decode the instruction and analyze the instruction. After performing the decode and analyze operations, then the system can get the data from the specified source register. Here, the source register is what? R6. The data is readily available in R6. The content of R6 is transferred to one temporary register RB. And what is called R8 means what? The R8, we need to store the data into that specified memory location. So before storing the data, we need to find the address. So that's why that the content of R8 is transferred to RA. Again, in third step, we need to find the address. So the RA will be added with the offset value of X. So you will get one address. Then that address uh, and the data where the data is available in R6, the data is available. That R6 is temporarily stored into memory register. Then the address is temporarily available in RZ. So in fourth step, we need to transfer that content of RZ. So the address will be transferred to memory address. Then here in that memory specified memory address, the actual data will be stored. Where the data is available means what? In register RM, the original data is available. So the content of data will be transferred to memory address. Here the system can perform the write operations. So the memory can be performed the write operations. So the step 5 not required. So load instruction alone can use all 5 steps, but store instruction, the first 4 steps are mandatory. The step 5 is not required. So I hope you understand this concept. Thank you.